Namaste and good afternoon. Today I am going to present the district mathematics in semester presentation. Okay, we are the topic is concept of mathematical inductions and facilitator by Mr. Sandeep Tungana sir, and it's me myself Binod Shr, and today we will discuss or I will present about the concept of mathematical induction, how induction method help to learn the mathematics in better way. Okay, induction method, it is known as the mastering mathematical inductions, the powerful proof technique used in mathematics, particularly a number theory combinators to establish that the given statement is true for all the natural numbers. From specific observations of general conclusion. Okay, in this interpreter, a powerful tool is for reasoning and learning. Okay, it involves we start with the specific observations or example, then the drawing general conclusion or principle from them. This approach often used in scientific research, problem solving, and everyday decision making. For example, we are going to learn what will be the square of the number. Okay, let's see writing tools here. Now 1 square, suppose 1 square equal to 1 and 2 square equal to 2, 4. Okay, now 3 square is equal to 9 and 4 square is equal to 16. Likewise, 5 square means you already know that 5 square is known as a will key result is 25, and 6 square is known as equal to 36. So by doing and learning, this is known as also by doing and learning. From by doing this square number, we will learn this side is like a odd number. Look at the odd number, and this is side is even number, EVEN. In this even and odd, we are just finding the result. Uh, we are finding the result is, look at here, 1 square 1, 3 square 9, and 5 square 25. Likewise, if we are finding the square of 7, we will get the 49, and 7 after another order is 9. 80, that's square of 9 is 81. Likewise, we are generalizing this concept. We will we have got that the square of the odd number, the result became also odd. Likewise, in even number, the 2 square equal to 4, 4 square equal to 16, 6 square equal to 36. Likewise, after 6, then another even number is 8, and 8 square is known as a 64. That is also even. Generalizing that the square of even number is always is even, and odd number square is odd. By like this generalizing, we will know the concept of the inductive method. Okay, I'm grabbing this one. Okay, just wait. And likewise, these methods are very uh, used in mathematics in basic concept. Okay, now unlocking the power of step-by-step proofs. Okay, by step proof, in this case, basic case proof to prove, we will work n equal to 1. We will do n equal to 1 and 1, and then uh, after 1 we will basic case, that means basic course and inductive hypothesis. Then after we inductive hypothesis, for suppose we will put the n equal to 1, then after n equal to k, that is hypothesis, inductive hypothesis. Let's suppose that we will assumption that the hypothesis may be right or wrong, and then after inductive steps, use the assumption to prove it for n equal to k. At first n equal to 1, then after hypothesis n equal to k, and then after inductive step use the assumption to prove it for n equal to k plus 1. Okay, why we use the mathematical induction? For mathematical induction, we use for core idea, exact idea. Just before we discuss about how to find the square number, how we get the result of square number, the square of even number is even, and odd number is, or result is odd. By taking this example, it have will get the core idea by doing and learning. Okay, next, it the first domain for basic case, and every domain ensure that next false inductive step, all the domain will be fail. And application, then after we will learn about the applications. Okay, and application means by doing that, if we are finding the square of 11, that is odd number, we will get that square of 11 also should be also odd number. That means the square of 11 also 121. That if we will got someone mistakenly someone got that 123, sorry, 120, then we will know about that is wrong. How to know? Because there is a odd numbers square should be in odd, and providing formula, it gets a providing formula, and so showing the divisibility also, showing divisibility. Okay, next. Okay, for example, here is also I have bring that example. Okay, example number 1, the sum of first n natural number is our problem, and now we are going to prove that the sum of Sn equal to, we are natural number, we know about the natural number means starting from 1, and we'll adding here 1 plus 2 plus 3 plus 4 plus 5, likewise dot 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 dot. By doing this, we will find the up to n natural number up to n is n times n plus 1 upon 2. To prove that, basic case here, basic case is how is it not working? Okay, while we are for n equal to 1, Sn 1 equal to 1 matches the formula. Likewise, look at there, if we are putting there the value of n equal to 1, 1 bracket 1 plus 1, you will get 1. That means 1 plus 1, 1 into 1 plus 1, and then you will get the same result. Inductive hypothesis, we will get the k plus k bracket k plus 1 upon 2, and this is our hypothesis assumption, and the inductive step is prove sk plus 1 equal to sk plus k plus 1 matches the formula. Okay, now example 2. In example 2, we have the problem to prove that the 1 square, 2 square, and 3 square plus up to n square, their result will be n bracket n plus 1 plus 2 bracket, sorry, bracket 2 n plus 1 upon divided by 6. For the solution, we will basic case that you have to put the n equal to 1 and matches the formula. Likewise, the induction hypothesis, that means assume the true for n equal to k, and inductive step prove it holds for n equal to k plus 1. By putting the n equal to 1, it matches the formula. And inductive hypothesis, that means you have to assumption that n equal to k, we have to manage that their k n equal to k, and likewise inductive step are the proof that it holds for n equal to k plus 1. Okay, next example number 3. In example number 3, we are going to discuss the how the proving the inequalities. Okay, that means we are going to prove the inequalities, and here the n square 2 to the power n is always greater than the n square for n is greater than and equal to 5. Its solution is for basic case, we are taking the smallest value there, is n is just greater than and equal to 5. So we are we are taking n as a first of all 5. So n to the power n means 2 to the power 5 means 32. Likewise, in the place of n we are writing here 5. So here 5 n square means 5 square. The result is 25. So we can say that it proved that the 32 is greater than 25. That it's clear that the concept base case is right. Now, so second step, inductive hypothesis assumption is 2 to the power k is greater than 2k. 2k square, sorry, 2 to the power k is greater than k square. So likewise, in by you following this concept, the inductive step will prove that the 2 to the power k plus 1 is greater than k plus 1 to the power 2, k plus 1 whole to the power 2. The conclusion show that the 2 to the power n is greater than n square for all the n is equal to 5, n is equal to or greater than 5. Okay, now let's take away the mathematical induction is by versatile tools to prove being the mathematical truth. Always verify the basic concept, basic case, and make strong assumption. By doing basic case, we will assumption that hypothesis. Then, after carefully, we will perform the inductive steps. For recap, we are doing first of all sum of natural number, then after square number, and providing inequality. The three example I have already shown there. Okay, now the last example for as a real life examples. A company wants to ensure that the tasks assigned to their employee and they distribute fairly. For tasks has specified difficulty level. The company claims that the total difficulty of the task assigned to the employee can be represented as the Tn equal to n bracket n plus 1 upon 2 that we have given the previous formula, where Tn equal to each of in Tn equal to n bracket n plus 1 upon 2, where each employee has assigned the task the increase in difficulty from 1 to 1 to 3 and so on. Okay, for next we are going to solve it in this way. First basic case, we are taking an employee, there is only one employee, then there is they receive the task total difficulty and easy, every works he or he has to do, he have to be done. And basic, from basic case we are doing inductive hypothesis. So for that we are writing the k in the place of n, so tk equal to k bracket k plus 1 upon 2. Okay, likewise, now prove that the formula holds that the n equal to k plus 1 t k plus 1 equal to tk plus 1 bracket k plus 1 using hypothesis substitution. Substitute tk equal to k plus k bracket k plus 1 upon 2, will get the result tk equal to k bracket k plus 1 upon 2 plus k plus 1. Okay, by saying this, I have in the presentation. Thank you so much. Thank you.